Hey y'all! All right, so we're gonna start at an intro to this roots of polynomials unit, but first I really need you to appreciate this video here. Do we get it? Get it like roots are like trees, and when we're finding the roots, we usually factor, so we're like breaking them up into little parentheses. I thought it was cool. Anyway, okay, so let's get started. So first I want us to look at these graphs, and I want us to tell us, what do you notice about the number of roots based on each degree of each function? Well, I noticed that I'm like, hey, this guy has degree 1 and it has 1 root. This has 2 roots and it's degree 2, so on and so forth. So this is actually going to be called the fundamental theorem of algebra. So every polynomial of degree n, assuming that n is greater than or equal to 1, has exactly n roots, including multiplicities, which I'll talk about in a second, and the roots may be a complex number. So let's think about multiplicities first. So the multiplicity of a root r is the number of times that x minus r is a factor of p of x. So if we think back to our quadratics unit, remember when the vertex was on the x-axis, it only touched it once, but it had a double root. Well, that's multiplicity was just 2 because the root was like maybe x is equal to 2, but it happened twice, so it was a double root. Similarly, sometimes in our quadratics unit, our parabola was above the x-axis and opened up, and it didn't cross the x-axis in the xy plane at all. But we're like, hey, just because it doesn't cross it in the xy axis, we remember that there are still complex numbers. So similarly to all polynomials, they have to have the same number of roots as the highest degree, but some of them could be complex. So okay, back to this idea of multiplicity. We've talked about this before, but really quick for an example, I want you to identify the roots and state the multiplicity. I will tell you if I don't want you to write it out. So here I say you don't need to write it out as points. Any other time I don't tell you, please make sure that you're writing roots as a point because it truly is where the graph crosses the x-axis. Okay, so looking at this, x plus 2, I'm like, hey, set that equal to 0. One of my roots is that x is equal to negative 2. This one, x minus 1, set that equal to 0. X is equal to 1. This guy occurs twice because it is x minus 3 squared. So I'm going to say that is a root 3. And then in parentheses, I just have multiplicity 2. If you were writing it as a point, you would put in parentheses 3 comma 0. And then beside it, you would just put MULT 2. So that's how you would write that there. Okay, cool. Well, I have this fundamental theorem of algebra. That's really cool. What does it tell us? Again, it tells us how many roots our polynomials has. But what it does not tell us is where are those roots? That's cool. I have like n amount of roots, but where are they? So in our next video, I will show you how to find it when you cannot factor, because some of our polynomials will not be factored, and that'll bring us to our rational root theorem. So watch my next video, and then I will show you guys how to find those roots.